All right, so chapter 5 is really all about solving equations. And so now we talked about solving quadratics the first two sections with the quadratic formula. Now we're going to talk about just solving generally a lot of different types of equations and general solving strategies. So the first section is 5.1.1. We're talking about solving equations algebraically, and we're looking at linear, quadratic, and radical equations. So there are two strategies we use to solve equations algebraically. They are undoing and then rewriting. The undoing strategy. When you use the undoing strategy, you're performing the order of operations backwards. Remember, order of operations is PEMDAS, so I often write it like this. PEMDAS for order of operations, but since we're doing it in reverse with a backwards arrow. Remember to undo each operation. You're not doing, you're undoing. Although we never called it undoing before, we solve linear equations by undoing and rewriting as well. So you've probably been doing this strategy for a while. You just may not have used these words. So just a quick recap for linear. Like remember, for linear, x to the first, you're trying to get all the x's on the left, all the numbers on the right. And so we're doing PEMDAS backwards because we undo addition subtraction. So again, I want the x's on the left, numbers on the right. So I'm undoing this plus 2, so I'm subtracting 2. And I want to get this x to the left, so I'm undoing a plus 3 by subtracting 3. And so I end up with 4x equals 92. And then I undo multiplication. Again, I already undid all my addition subtraction. Now I'm undoing multiplication divisions. I'm undoing this multiplication by dividing by 4. And 92 divided by 4 is 23. Real quick, one more example. Now I would also need to rewrite. Rewriting is where I'm just going to kind of rewrite it in an equivalent form. We'll go over rewriting in a little bit, but I'm going to rewrite now by distributing. So 7.5x plus 7.5 times 4.2 is 31.5 plus 4x equals 7.8. And so now I'm combining like terms. So again, I'm rewriting it again, a little bit easier form. And now I undo addition subtraction. So I'm subtracting 31.5. And I get 11.5x. 7.8 minus 31.5 is negative 23.7. And I divide by 11.5. And I get negative 2.06. All right, so again, that's the simplest form of rewriting or undoing. I'd like you to try some of these on your own. And we're going to move on to the undoing strategy. All right, you can also use the undoing strategy to solve quadratic equations that only have a single x squared or in the equation. So like a parenthesis x squared in the equation I'll put. So if you look at example 4, we have this big old parentheses squared. There's nothing else in there. Okay, there's no other x's, no other x squareds outside of that. So this is where we can use the undoing strategy. It actually makes life much easier. So I am undoing anything added or subtracted to this parenthesis squared. So I'm going to add 5. That gives me 3 times the quantity of x plus 3, quantity squared, equals 27. I'm going to divide by 3. And that would give me x plus 3, quantity squared, equals 9. Okay, so I already undid addition, subtraction. Then I undid multiplication, division by dividing by 3. So I'm working my way back through PEMDAS. Now I'm going to undo exponents. So to undo a square, remember you're going to take the square root. And so I get x plus 3. And I don't need the parentheses anymore. Equals. Now, since I wrote the square root to solve, this is saying what times itself, 2 times is 9. And this is where you must have the plus or minus, because 3 times 3 is 9, and negative 3 times negative 3 is 9. Whenever you write the square root, that's when you need plus or minus. So now, I'm going to have 2 equations. X plus 3 equals positive 3, and x plus 3 equals negative 3. The biggest mistake is people don't put the 2 answers. We subtract 3, so we get x equals 0. Subtract 3, x equals negative 6. Pretty straightforward, and that makes it much easier than some other solving strategies. All right, if we look at x number 5 as well, and we're doing PEMDAS backwards, so undoing addition, subtraction. So here I have adding 6, I'm undoing adding 6 by subtracting 6. Next, I undo multiplication, division. Well, there's multiplication right there, so I'm dividing, undoing multiplication with division. So I have x minus 2 quantity squared equals 9. And now I undo exponents, take the square root. I get x minus 2 equals 3, but again, I would need plus or minus 3 because I am taking the square root myself. I'm writing that square root to solve. So x minus 2 equals positive 3, x minus 2 equals negative 3. Again, I'm getting 2 answers. So I add 2, I get x equals 5, add 2, and x equals negative 1. All right, how about you try on page 7 at the top? Again, we're looking to do PEMDAS backwards. So I would undo addition, subtraction by adding 2. And so that would give me 80. And then I'm going to divide by 5. Which is 16. So we're going to end up with x minus 5 quantity squared equals 16. Again, I undid addition, subtraction. Now I'm undoing multiplication, division. So I undid multiplication with division by 5. Now I'm going to undo the exponent, the square, by square rooting both sides. The square and the square root cancel out. So I'm left with just x minus 5. And since I wrote that square root, I'm going to have plus or minus 4. We write 2 answers. X minus 5 equals 4. X minus 5 equals negative 4. And I end up getting x equals 9 as one answer. And when I add 5, x equals positive 1. So get that? Good job. All right. We can also solve radical equations by using the undoing strategy. So again, radical equations have the square root symbol in them, or a cube root for that matter, or a fourth root or a fifth root. But we're still using that PEMDAS backwards. So I look to undo addition, subtraction. Now, the only subtraction I have is right here inside that radical. That radical is protecting. It's protecting this whole thing. So right now, it's like a bodyguard saying, hey, you got to get through me first. So right now, we cannot undo any addition, subtraction. So guess what? Not a big deal. We'll just go and try to undo multiplication next. So I'm going to divide by 3. And I'd end up with the square root of 2x minus 1 equals 5. And now we're like, all right, square root, I can defeat you. So we undo exponents now, which is really a square root. What's the opposite, or how do you undo a square root? We're going to square it. So we'll square this, square that. So the square and the square root cancel. So we're left with just 2x minus 1. And then we have 5 squared. And 5 squared, remember, it means 5 times 5, which is 25. So you only get a single answer here. A lot of times people want to put plus or minus, but when you're squaring, 5 times 5 is just 25. You're only going to get one answer here. And now we're kind of going back up here, undoing addition, subtraction, add 1. 2x equals 26, and then we undo our multiplication, so x equals 13. For example, 7, again, we're undoing addition, subtraction. We're adding 3. So I get 7 square root of x plus 1 equals 21. I undo multiplication, division, which is 7. I still have that square root, though. So to undo a square root, I'm going to square each side. And I'm going to get x plus 1 equals 9. And then I'm going to subtract 1. So I end up with x equals 8. All right, go ahead and try this one on your own. Okay, so you're undoing the subtraction, the addition first with subtraction. You're going to undo the multiplication with division. And so you're left with square root of x minus 7 equals 2. You're going to undo the square root by squaring, because the opposite of square root is square. That cancels the square root, so you're left with x minus 7 equals 4. Add 7, x equals 11. All right. It's always a good idea to check your solutions. It's always a good idea to check your solutions. To check your solutions, you substitute your answers in for x in the original equation. If the statement is true, you know your answer is correct. If the statement is false, your answer is incorrect. You gotta go back and check your work. So it says, let's check our answers for example 4. So example 4 was on the previous page here. We had 0 and negative 6. So we had 3, and we go 0 plus 4, 0 plus 3, quantity squared minus 5 equals 22. Because again, we got one answer of 3 and the other would be negative 6. So we have to check both of them. So here's x equals 0 check. So 0 plus 3 is 3. We have to follow PEMDAS here, so we do have to follow order of operations. I square next. 3 times 9 minus 5 equals 22. 3 times 9 is 27. And then 27 minus 5 is 22. So 22 does equal 22, so that's a check. And then we also have to check negative 6. So for negative 6, we would say 3 equals negative 6 plus 3 squared minus 5 equals 22. Negative 6 plus 3 is negative 3. So remember, negative 3 squared is positive 9. And then we have 3 times 9 is 27. Minus 5 equals 22, and 27 minus 5 is 22. So we get 22 equals 22. It does check. So we know both our answers for example 4 were correct, because when we plugged them in, we got a true statement back. All right, and that's where we're going to stop for now.